Hello guys, welcome again to another video on our fundamentals of electric circuits. So in this video, we're gonna explore Ohm's law, okay? Ohm's law is the most famous and most important law in all electric circuits. This is basically the fundamentals of the fundamental of the fundamentals, So Ohm's law is so simple. V equal to IR, we know all of that, and this is just, a background, a refresher basically for it. So let's assume we have a simple circuit like this one here. You have a resistance, we have a battery, and we can change the battery voltage. Okay. So we bought or we set the battery, for example, for let's say 10 ohms, R1, any value. Then we change the voltage of the battery from 0 and then maybe 1, 2 volt, 3 volt, 4 volt, and so on. And each time, each step from 0 to 1, 1 to 2, we measure the current. Okay? When we draw the relation between the current and the voltage, it's going to be linear, like this one here. And it has some slope. Then we remove the battery, the resistance, and put another resistance, which is maybe larger, maybe or smaller, R2. Okay, R2. We redo the same steps. We change the battery voltage 0, 1, 2, 3, 4, and so on. Okay, and again we draw. Again, we're gonna find we have a linear relation between V and I, the current and the voltage. But now, since the resistance reduced, the current increased. The slope become higher. Let's decrease more the resistance. We bought R3, which is less than R2, and R2 less than R1 even. So it is less than both. And we redo the cycle, change E or the battery 0, 1, 2, and each time measures the current. You're gonna have like a much bigger now slope. Okay. So we can conclude all of that into like relations. I is disproportional to the resistance. When we increase the resistance, of course, we decrease the current, because the resistance is basically a resistance for the charge that carries the current. And when we increase the voltage, we increase the current. When we decrease the voltage, we decrease the current. So it's a proportional relation. Okay, so we can gather both these into that equation, very simple equation, V equal to IR, and that's basically Ohm's law. The voltage across the resistance is equal to the current going through the resistance times the resistance. Very simple. Let's have two examples in here. The first example, you have a resistance 5 ohm, you have a battery 10 volt, and we need to know the current going through the resistance. To apply Ohm's law, we must know the voltage across the resistance, VR, okay? And if we again review the fundamentals, V and I across the resistance are opposite to each other. So if the current is going that way, V will be that way. That means that's the positive, that's the negative. Now looking at this circuit, you're gonna notice that the terminals of the resistance are exactly same as the terminals of the battery. So if the terminals are the same, that means the voltage is the same because they are parallel, okay? And as we studied before, a parallel connection means the same voltage, okay? So here, basically, VR is equal to 10, and IR from that relation, Ohm's law, will be equal to V divided by the resistance. So IR equal to 10 divided by 5, 2 amperes. Good. Let's now, same circuit, but I doubled the value of the resistance from 5 ohms to 10 ohms. Let's see what's going to happen. Again, the resistance has the same terminals as the battery, so they have the same voltage. So VR equal to 10 still. IR still equal to V over R, or VR over R. Let's be too specific here. So IR now equal to 10 divided by 10, it's 1 amperes. Oh, we increase the resistance, we decrease the current. And look at that. We doubled the resistance, we halved the current. We doubled the resistance from 5 to 10, we halved the current from 2 to 1. That's always, the case. With the same voltage, of course. Okay, guys, that was basically Ohm's law. Thank you very much for watching and see you in another video. Bye-bye.